Hello everyone, Dr. Zia Tahir here. This tutorial is about 3D steady-state heat transfer analysis in Abacus Workbench. Specific problem is steady-state conduction and convection through a slab. So this is a slab and its one face or one surface is being shown here. So slab shown in the figure as thermal conductivity of 15 watt per meter per degree Celsius. The top face of that is maintained at 250. The left face is maintained at 40 and the other two faces are exposed to environmental free stream temperature of 40 degrees Celsius and convective heat transfer coefficient of 60 watt per meter square per degree Celsius. The thickness of slab is 10 centimeter. So the thickness is not shown here, or the depth of the slab is 10 centimeter. So this problem is a modified version of problem 13.25 from chapter 13, heat transfer and mass transport, from a book, a first course in finite element method, Daryl Logan 6th edition. So that is a statement, and what's required. Determine temperature at the center of the slab, so somewhere here in the center, and plot temperature distribution on front surface from top to bottom passing through the center. So that somewhere here is required. So this is a second lecture of the series. You can watch first lecture, which is the steady state heat transfer conduction through plate, and in that folder, oh sorry, in the playlist, ANSYS Workbench Thermal Analysis. So here are steps to perform this analysis in ANSYS Workbench. The first one is project, then engineering data, then geometry, then model, then setup, then solution, and then result. So these are steps. These are steps. So I'm going to follow these steps. So these are the main steps, but there are some sub steps in that. So I'll follow all those steps to solve this problem in ANSYS. So the first step is to start a project which is steady state thermal in ANSYS Workbench. So that is ANSYS Workbench, and in ANSYS Workbench, so there is a toolbox. In the toolbox, there is an analysis system, and then in analysis system, I'll double click on steady state thermal. So in the steady state thermal, there are further like the first one. These are the steps. First, steady state thermal, then engineering data, geometry, model, setup, solution, and then results. So I'm going to save that model somewhere. So as it's your choice, I'm going to slab, steady state, conduction, and convection. Second step is engineering data, and in engineering data, need to add material. And for steady state thermal, the only property required is isotropic thermal conductivity. And the thermal conductivity of this material is 15 watt per degree Celsius. So for that one, double click on engineering data. So once you double click on engineering data, so you have here this outline of schematic of engineering data. So click here to add material. So I am going to add material. So now the material is being added, but there's a question mark on that. So from here, I thermal conductivity drag to that material, and there you have its value. And the units for that are like the units here. They are watt per meter per Kelvin, degree Celsius. So these are the units. So if you have different units, select from there, and that is 15. So now the material, that material has been created. So you can save that material. Once material is saved, so you can close that tab. Next step is in the geometry module, select analysis type 3D. So that is here in the geometry, and analysis type by default is 3D. And then in the geometry, start new design modular geometry. So right click on geometry and new design modular geometry. It will take some time to open that design. So in the design modular, you need to sketch and then add dimensions. So for that one, I want to sketch that in XY plane. So in XY plane, so first you need to set units. So let's say I'm going to use centimeters, and here you can see that one, like the maximum is 200 centimeter, 100 centimeter. Okay, so for that one, here you have modeling and then sketching. So I want to draw that in XY plane. So for that one, you have option. So here you can go to the setting, grid, show in 2D, and then snap and major spacing. I am going to use that 10 centimeter and a step, just one step for that one. Okay, so draw. I'm going to draw that first. So that is, so here let's say that is 100 somewhere here. So I just want to go 200. So that is, here is 200, and then like this one. Okay, so that is the front face. So now here in the dimensions, so first display and then general. So that is 100 centimeter, and that is 100 centimeter. And if you want to change it from here, so you can just change that one. So next go to the modeling. So here you have that sketch. So now extrude. Now it says that, so that sketch is being selected and then extrude. So it says that here direction vector, so extrude, apply, and then is 20 centimeter. By default it is 20 centimeters, so the thickness is 10 centimeter. And let me, okay, and then it is toward this side, so just direction vector, sorry, so that is towards z axis. So if you want to reverse that one, so you can see it is going other way, that is going other way. Let's say I can see from here. So if you want to go normal to that, so that is along z axis. Okay, so in this way that is being extruded. So apply that. So once it is extruded, so then just generate it, and now you can see that it is being generated, and then I can add dimensions for the third one. So its dimensions can be added. Now that model has been created, which is 100 by 100, and then its depth is 10 centimeter. So in the geometry, design modular geometry, extrude its direction, then giving it depth, and then generate it is. Next step is model, and for that one, you can go here workbench, so you can see that these two ticks and then the model. So double click on that, and it will take some. Meantime, I'm going to rename that solid as slab, and then I'm going to save it. So here is that model, and in that one, the step is to assign material. And here in the geometry, you can see that slab there, and the material for that, the default material is structural steel. So I want to add a new material which I have added there. So now for that material, so for that slab, the material which is defined, that is the next step is create a path in the construction geometry. Why is that required? Because uh, we need to plot the temperature distribution from top to bottom. So that way, a path need to be created from top to bottom. So path, you need give it any name. Then definition 2 points. So for that one, here on the model, on the model, so you have here construction geometry and then path. Now need to give the coordinates of the path. So I want to create path on that front surface. And for that one, I need to check that where are the coordinate systems. So coordinate system, they are somewhere right there. So I want to draw it somewhere from the top. So it's mean that for the path, it is x coordinate is 0.5, y coordinate, I am taking it as 1, and z coordinate as 0.1. And similarly for this one, you can see that it is right in the middle of the front surface. So that path is being created. So you can just rename that one path. So let's say path A. So that is, you have given it a path name. The next step in the model is mesh by giving any element size and then to generate that. So here, click on mesh, and now it automatically generated some mesh, and the element size is a default one for that. Okay, so I want to keep that element size as 0.1 meter or 10 centimeter, and then need to update that mesh. So now that mesh is being updated. Okay, so element size can be changed from here. That can be changed from here, and the units here are meters, kilogram, Newton, and then for temperature it is Celsius. Next step is to apply boundary conditions as steady state thermal in steady state thermal tab, and for that one is temperature and other is convection. So the top surface is subjected to 250 degrees Celsius temperature, and that left surface is subjected to 40. And then these two surfaces are exposed to free stream environment. So here we have convection. I'm going to apply temperature boundary condition, and for that go to environment, temperature, and then scope, geometry, phase, and then the definition of the magnitude. So for this one, here click on steady state thermal, and then you have temperature here. Or otherwise, right click that, insert temperature, and then now from here, select face. So that top face is being selected, apply, and the temperature on that is 250. So that 250 degrees Celsius temperature is applied on the top surface. So I am going to rename it as top. Then on this left surface, the temperature need to be applied, and that is 40. So again here, so temperature, I'm going to rename that as left edge, and then just rotate that. Okay, and then from here select the edge. So that is being selected, apply, and then temperature is 40. So now on those two surfaces, here the top 250 applied, on that left 40 is being applied. The next one is to apply convection boundary condition, and for that one again go to that modeler and design modeler. So now need to apply boundary condition, convection boundary condition on these two edges, and for that click on the convection. Okay, so I can rename that as right and bottom. Okay, so for that one, here you can select that one face and with control the other one. So apply, you can see that two faces, and the value of uh, convective heat transfer coefficient is 60 watt per meter per Celsius. So now that boundary condition is being applied. So now you have three boundary conditions applied, two temperature boundary condition and one convective heat transfer boundary condition. So now these are the temperature boundary condition applied. Okay, and then convective heat transfer being applied. Next step is solution. Solution, temperature is required at the center of the slab, and then temperature distribution along that. So for that one, thermal, uh, in the solution, click on the solution, then go to thermal, and then go to temperature, and then specific node at the center. So here in the solution, then in the solution, if you click on the solution, so you will have that tab, so thermal, temperature, so that temperature is required for all that slab, and then what, and then the temperature right somewhere in the center is required. So for the temperature in the center, I am going to select a node, and here you have option to select node. So that node from the top surface is being selected. So then go to solution and then thermal. So the node in the center, it is being selected. So I'm going to rename it as center. So next step is temperature required along that path. So for that one, the scoping method is path and then give the path name. So for that one, again thermal, temperature, and I'm going to rename that as along that path. And for that one, scoping method, click here and path, and the path name is path A. So that is now being selected. So now in the solution, whatever is required, the temperature, overall temperature at the center and temperature along the path is required, that is all done. So now I'm going to solve that one. So once it's solved, so you can see the right ticks on that. After solve, the next step is results, and temperature is required at the center and the node is chosen for that one. So that is overall temperature distribution. So you can see that that is the overall temperature distribution for that one. Maximum is 250 and the minimum is 40, and then that is a variation. And then in the center, somewhere in the center, the temperature is 106.74 in the center. So next is to get temperature along that path, which is in the center of that plate. So for that one, here the path is being created, and for that path, it is usually by default it is a 47 steps. So I just want to check that 20 steps I want to see it. So just evaluate or solve it. It will now along that path you can see that is the graph, like on the top it is on the top is 250, and as you go down so it is 54, and then right in the middle it is 106.74, and that is the temperature distribution. On horizontal axis that is 0 to 1, like from the top to bottom, and then the temperature right below is 54, and then on the top is 250, and that varies like as parabolic form. So that is step by step analysis done for that slab. Okay, so you can check its temperature distribution on the back is the same one, okay, as it is in the on the front side. So that is the end of that analysis and the summary of that analysis. So as is a steady state heat transfer analysis, so you need to start a project steady state and then you need to add some materials. By default is structural steel, so you can add from the material library. So in the geometry analysis type is 3D, and you need to start a design modular geometry, and then where you need to first sketch the front and then you need to extrude it, and you can specify any direction and you give required depth. In the model, you need to go to geometry and then you need to assign material. So once a material is being assigned, so that construction geometry that is not necessary because it is asked in the question to plot the temperature distribution from top to bottom of the slab. So that's why it's being done. So then in mesh, the most important is the element size. So you need to select appropriate element size and generate. In this video, I have used that default uh, element type and then element shape. Then you need to go setup and apply boundary condition, and you need to click on the steady state thermal, and two boundary conditions need to be used here. One is temperature and the other one is convection, and then there are two temperature, like one for the top surface and one for the left surface. So then the solution, overall temperature contour plot is required and temperature at the center is required. For that I took the node and then temperature along the from top to bottom, and for that one I took a path, and finally you solve it, and in the results temperature at the center by using node is done, and then temperature along the path is calculated, that is being plotted. So this is all about this tutorial. Thank you very much for watching. So you can leave comment for your feedback.